Hello, everybody, and welcome to Thermal Engineering Concept and the Principle channel with Professor Ali Tarrad, who accompanies you in this series of geothermal energy applications in power plant. We talked about other two types. They were dry steam geothermal power plant, and then we talked about um, flash steam geothermal power plants as a single and dual tanks. In the present episode, I will talk the last type of these plants, which is a binary geothermal power plant. So let us pass through the contents of this video. Objectives of the present video will focus on the geothermal temperature profile as described before in other episodes, the previous two episodes as well. Uh, the binary geothermal power plant, which is the last type of geothermal power plant for electricity production, and then we will go to closure as usual to talk uh, about the contents of the video and the subjects which has been uh, passed through. Now let us consider the geothermal energy and the temperature variation as we go deep in the ground. We may find this table in the open literature, which shows the variation of temperature with depth. For example, for depth between 10 meters up to 200 meters, then the temperature will be around 30 Celsius. If we go deep to 2.5 kilometer, then the temperature may range between 30 and 90 Celsius. And if we go more deeper in the ground, up to 5 kilometers, then the temperature will be more than 150 Celsius. Of course, this range of temperatures and depth gives a sort of guide to know about the temperature variation of Earth with depth. But again, it depends on the climate and the geological structure of Earth. There is a term called a geothermal gradient, which refers to the average rate of temperature variation with depth. For example, in Europe, the geothermal gradient approaches 30 Celsius for each 1,000 meters. Of course, this is again a general guide. It depends on the earth where we are dealing with. For example, in Iraq, uh, some of the studies show that the temperature variation is around 21 Celsius per 1,000 meter, and maybe in other places you will find another value. So it depends on the climate and where we are treating these values for geological effect. Binary geothermal power plant, as its name describes, the process that is consisting of two main circuits. where we need um, an intermediate cycle to extract energy from underground. And usually, this type of power plants are used where we have temperatures uh, between 107 and 182 Celsius. And in that sense, we are talking about low temperatures of the geothermal source. So, uh, hot water is extracted from the production well through a piping system and then will pass through a heat exchanger where the heat is extracted from water before returning it to the injection well. So the fluid which is circulated in that heat exchanger vaporized and then passes through a turbine, which is a part of a Rankine cycle, to produce electricity with the aid of a generator. And in that sense, we are going to produce electricity and supply it to the national network, for example. And the steam is condensed uh, in this way, we are talking about steam, referring to the vapor of the um, organic fluid which is circulated in that cycle. And then it is a closed circuit which will be described later for the uh, organic fluid which is circulated in the heat exchanger. In details, we may describe it. Describe the binary geothermal power plant in this animated illustration. The hot water is supplied from production well, passing through an evaporator to vaporize the organic fluid which is circulated in the second circuit. So, uh, what happened here? That the fluid or the hot water is passing through the heat exchanger, which is evaporator or boiler, and then when it leaves, it passes through a preheater. And this is to get as much as we can energy from the hot water before rejecting it back to the injection well. And in this way, we are improving the thermal efficiency of this cycle. So the fluid then, which is usually an organic fluid, such as normal pentane or isobutane, vaporized and then passes through the turbine, which uh, produce rotating energy that is transmitted to electricity by passing it through the generator, and the steam will leave the turbine at low pressure, condensed, and then pumped through the pumping system or a pump which is operated in connection with a motor which takes electricity from external supply, and the liquid passes through the heat exchanger, preheated, and then injected to the boiler. So that is called a binary geothermal energy. And even the efficiency which we are talking about is it is calculated on the same manner as before. That is efficiency equal to W divided by m dot times H source times 100. And the general values for these binary systems are ranged between 7 and 12 percent at low temperature, and these values may approach a value of 20 at high temperature of the energy source supply, I mean the hot water from the underground. So in general, all these type, dry steam or flash steam, or even the binary. In general, all of these give a range of conversion efficiency range between 7 and 21%, and an average value, global value internationally for these plants which are used in different countries gives a sort of average value which is about 12%. And now we reached the last part of this video, where a closure to describe what we passed through in this episode, that the geothermal energy and its use in power plant. And we describe the last third type of geothermal power plants, which is the binary system. And in that sense, we say that these three types, the dry steam, the flash steam, and the binary, these are the um, types of geothermal power plants used to produce uh, uh, electricity. And if you think that this video is useful to you, and others, please subscribe and share it. And I will see you in the next episode in the field of thermal engineering, energy management, heat transfer, and goodbye.